started the recording late, then here you go. It's all there. So you'll use this one when the population standard deviation is known. Which again, I said it's really weird because if you know the population standard deviation, then you probably actually already know the true mean, right? So, here we go. So we're going to go to the real thing. So in real life, when you're actually trying to do a confidence interval, you don't know the population mean or the actual mean. And what's going to happen is it's going to follow a different distribution. So we now are going to introduce a t distribution. So in order to standardize, I'm going to actually go straight to this. If we're going to standardize something that is a simple random sample, we're going to look at it as a t distribution. So, t distribution. Alright, so if we take an SRS, a simple random sample, we're going to do it from a large population, or large enough, right? Large enough to assume normality, right? In this case, we're going to say that that's assumed. We're going to say the statistic So that is true for if it's normally distributed. But if we have a sample that's large enough, right? In other words, the sample size is larger than or 30 or larger, right? And we can assume it's normal. But then, so for a sample size large enough, we'll just say. We'll say that this statistic will have approximately T sub n minus 1 distribution. Cool, so we'll be calculating critical values based on our sample size, degrees of freedom, and we're going to use those values in that T table that I've already given you. So, and we're going to use it very similarly to the way that we used our Z table, our Z distribution, for our normal distribution. And we're going to get into that. I think we have time right about now. Yeah, total. Let's do it. All right. So you all have your T tables? There we go. So let's go ahead and use our T table right now. We're going to figure out our critical values using constructing a confidence interval in the following settings. Let's find a 90% confidence interval for a simple random sample of size 10. So, first thing we need to do is calculate our degrees of freedom. So our degrees of freedom is equal to n minus 1, which in this case is going to be 9, right? Then we will go to our table. There you are. And we will find 9 on our table. What do we want? 90%. When do we want it? Now. Just kidding. And let's find where these guys match up. So we got 90%. Sorry, he said 90? There we go. So we're going to use 1.8 as our critical value. Did I match them up right? Shit. Okay. All right. 1.833. Beautiful. So our critical value T star is equal to 1.833. Let's do it again. So for B, our degrees of freedom is 95 minus 1, or 94. All right, so let's go to our table and see what's up. Sorry. So what are we going to use? There is nothing there, right? So let's use 80 to be conservative. And it said 99%, right? So 80 at 99, 2.639. So it's time to learn about properties of algorithm. I'm sorry. It's It's okay that you showed up late. We're just glad you're here. Glad you're here. So if you put this one inside of your calculator, log base 10 of 2, I think you'll get this approximate number right here. Go ahead and get out your calculator, type that in, and you're gonna see that when you don't have a number in your base, it's actually 10. Oh no, I just messed up AP statistics video.